Hello, welcome back. I just want to go through a very quick, small code segment I just posted to the board. Previously we were talking about drawing transparent strips, and one of the limitations of the strip commands, which are under graphics down here somewhere. Graphics. You've got the, where are we? Textured strip, and which draws a horizontal strip or a vertical strip, so you can do slices of an image and split the image up, that kind of thing. There's a ground version of it as well. One of the limitations of that command in particular is it doesn't support transparency. I never noticed this until recently, actually. I think the plan was to add that, but it must have just fallen off the radar. So how do you emulate that when it's not actually part of the product? Well, what you can do is you can use the TextureQuad, which is really the same kind of thing, but we can limit the part of the output we're drawing to. So we can sort of simulate drawing a strip of vertical pixels or a horizontal strip. Here I'm using vertical strip. And I'm sort of just drawing a texture fragment with sine wave applied to it. Nothing all that interesting, to be honest. So they've got the ball being stretched and having a sine wave controlling its height. Normally what you would have to do is you have to render all those strips to a secondary buffer and then split that buffer over the background with transparency. So this is one way of doing it. The code itself is anything but optimal. So we're loading the two textures with the bubble texture as effect surfaces. I could probably just do the backdrop actually as a normal video image. Just check that. So before there was issues with capturing this. See if it captures okay now. Yeah. Very strange. But anyway, the actual code itself. The background is just a tile image with a modulus to simulate the scrolling. It's not interesting. This is the portion that controls drawing strips across every every vertical row of the screen, giving them different heights, etc. But they're centered around the middle of the screen. This function here is what we're looking at that emulates the TextureStrip vertical command. We're giving it an image and what strip from that image you want to draw, and then the output location that we want to render to, and as well as the top point and the bottom point. So these can be stretched. So we're not doing a straight copy of that image fragment, we're doing a scale of that fragment. We're checking if the source and destination are within the current target surface. If they're outside, we just ignore it. Now, a lot of this kind of safety code can be got rid of if you want to do this in a brute force way, but here I'm just kind of adding a function that sort of does this task. You might have to clean it up a bit yourself, actually. We're running through, grabbing the current surface and remembering that for next time. Grabbing the current viewport, so we're going to be changing the viewport as we're doing this effect. So we'll need to restore this at the end of the function. So if you call it, you're not changing the state. We're grabbing the texture width and height, setting out the target Y for where the strip's going to be rendered to on the screen. We subtract the current X coordinate. Because we want to draw a strip, we have to sort of line the strip up with this viewport. So we're going to set the viewport up to be the strip we want to rendering into, and then draw the image or this rectangle as if we're scrolling it left and right to show a vertical row of it. That's what the strip X is doing. Depending on what surface we're drawing to, we use the image viewport command or screen viewport command. In all seriousness, what you would do is you would work this out up ahead and then do all of your texturing inside a tight loop and then restore it later on. But anyway, so we're drawing calling TextureQuad, to draw. Actually, we're drawing a scaled rectangle, but the only part that makes the screen is that vertical strip that we're interested in from the texture. Well, hopefully anyway. And it's drawn transparent because TextureQuad supports a transparent flag. This is probably one of the most awkward functions in PBASIC. It has so many parameters. As you can see, you've got to supply the texture, and then the top left-hand coordinate, then the top right-hand coordinate, the bottom right-hand coordinate, and the finals, the bottom left, and then the transparency flag at the end. So pretty ugly. Yeah. A few examples tacked on the outside there. Getting back to here, so we're using the TextureQuad to do its job, restoring the viewport, and then returning. So we're drawing one strip at a time from this thing scaled vertically. And that's the whole application. Run it one more time. Performance wise, it actually runs pretty well. So we're doing a full screen vertical strip here. If you're emulating something like, or trying to write a modern version of something like a Wolfenstein 3D, for example, those games were written to run in 320 by 200. So we're running here 800 by 600, I think it is. That would be the standard size. So it's, a factor of probably 6 times the amount of data, probably 8 times the amount of data in BASIC. Just as a bit of a mock-up for you. That'll do us. You can find the example on the boards. It'll be over here on the boards, using TextureQuad to draw transparent texture strips. That's the one. Thanks for watching. I'll see you next time. Bye.